communication systems அப்படிங்கிறது communication purpose அப்படிங்கிறது நம்ம எல்லாருக்கும் தெரிஞ்சது தான். இப்போ நம்ம அந்த communication applications தான் யூஸ் பண்ணிட்டு இருக்கோம். So in this lesson, so we are going to see the எல்லாரும் மைக் ஆஃப் பண்ணிருங்க. Okay. So in this lesson, we are going to see the basic elements of communication system, need for modulation, propagation of electromagnetic space, and satellite communication, fiber optic communication, radar, internet, and global positioning system, and application of the communication technology. So first we are going to see that introduction. In this lesson, we are going to see that the electronic communication system, the first, that 1874, 44, and 1005, the J.C. Bose and the Marconi and Alexander Graham Bell are the scientists first invented that radio, telegraph, and what is the another one thing? Telephone, telegraph, and radio. These are all the things are communication devices used in the 18th and 19th centuries. Okay, then 18th and 19th century. After that, in 20th century, the very big leap of the communication systems. So we can transfer the data from one place to another place, and we can transfer the data in a very secure manner. So it was helpful of the global positioning system, satellite, mobile, and optical fiber communication system. These are all the things also to communicate the concept of communicate the peoples and everything. So electronic and communication and its applications. So these things that we are going to see in this lesson. Next we are going to see that modulation. Modulation is a very important thing. Before that, we have to know the sine wave and the communication system. In that communication system, the important thing is the electromagnetic waves. The electromagnetic waves are in the sine wave form. You know the property of the sine waves. See, in this wave, it has a crest and trough. You know that maximum displacement of the particle is called amplitude. That one complete vibration of the particle is called wavelength. That is lambda. Number of vibration per second is called frequency. That is mu. Frequency equal to number of vibration per second. Then that lambda is the wavelength, mu is the frequency, E is the velocity of the wave. The complete wave is denoted the equation EC is equal to capital EC sine 2 pi mu c t into t plus pi. Here EC is the potential difference of the carrier wave. That capital EC is called amplitude of the wave, where 2 pi mu is the frequency of the wave and plus pi is the phase of the wave. So the complete equation explains the wave form of the equation, that is sine wave. Okay. And you know that modulation. Modulation, you don't know that. Initially, we are speaking that the energy of the sound is a few meters. இப்போ நான் பேசுறேன் அப்படின்னா the sound எவ்வளவு தூரத்துக்கு கேட்கும்? It may be the 10 to 30 feet. After that, you can't hear the sound because that energy of the sound is decreases. So that energy of the sound is not enough to reach that long distance more than that 30 feet. So suppose we want to transmit the sound energy or the signal into a long distance, we need a large amount of energy. So here the 20 to 20,000 hertz that audio frequency that is used in the signal, that is the audio heard by the human beings. So that particular frequency is sent into that long distance mean we need the extra energy or the carrier wave. That carrier wave means it is a high frequency electromagnetic wave. That waves are used to transmit the signals from one place to another place. Here for a long distance transmission, that low frequency based signal input signal is superimposed on the high frequency radio wave is called modulation. That means that waves, the sine wave, the sound wave or music or whatever it is vibrating in the form of sine wave. that wave is superimposed on the high frequency carrier wave. So that is called modulation. So here the frequency of the carrier signal is very high. That means it is transmitted into a long distance. When you transfer the signal from one place to another place, definitely there is a change in the signal. That is called attenuation, or that is reducing the strength of the carrier wave, or the energy loss of the signal. It's called attenuation. Definitely the small amount of energy is lost. So this is the equation of the sine wave, where mu c is the frequency, E c is the amplitude, and pi is the phase. So these are all the very important factors for the wave. So here now audio frequency, know that from 20 to 20,000 Hz, that modulation has the three types. One is the amplitude modulation, frequency modulation, and phase modulation. So three factors of the wave. Sine wave, we know that frequency, number of vibrations per second, amplitude, that is maximum displacement of the particle, phase. Phase is the angle of the vibrating particle, you know that. So these are the three factors. Using the three factors, we can modulate the wave. That three methods are amplitude modulation, frequency modulation, and phase modulation. So first one, we are going to see that amplitude modulation. Okay, are you listening?
Yes, sir.
Okay. Okay. So now you see that amplitude modulation. That first wave, see the first wave. The first wave is the signal. What is a signal? It is called input signal, or it is called baseband signal. Baseband signal or input signal. That means basic signal. That is the signal, or music, or song, or the data, or the video signal, or picture, whatever it is. That's called signal. That's called baseband signal. So this is a baseband signal. That signal we can't transmit near very long distance because it has very less energy. So we are not able to transmit a long distance. So it requires carrier signal. So second picture, you know that is called the carrier picture, carrier wave. So the carrier wave is producing a large number of frequency. Amma yaro microphone on la off பண்ணுங்க. So this is called a carrier signal. The carrier signal, it has the frequency is very high compared to the input signal. See, you can see the picture. It has a very less number of frequency. It has a large number of frequency. So high frequency carrier wave, less frequency signal wave. So here the three factors: frequency, phase, and amplitude. It has a three factors. In amplitude modulation, we are going to change the amplitude of that wave according to the input signal. அப்ப input signal தகுந்த மாதிரி carrier wave ஓட amplitude change பண்றதுக்கு பேர் தான் என்னது amplitude modulation. So that based on the input signal, the carrier wave is changes. It's called amplitude modulation. See here. So this is a carrier wave and this is a signal wave. Okay, you see the signal. It's a signal waveform. The waveform is here. So here, so you can see that the two bands are here. See that black color line. Above the black color line is called upper side band. This is called lower side band. Okay. So envelope of the modulated signal is here. So that center maximum is called maximum amplitude, and this is called minimum amplitude. Okay. So this is amplitude modulation. So modulation means that high frequency carrier wave changes its amplitude depending on the input signal. Is called amplitude modulation. Right? So the first picture explain that. So this one is okay. So here, what is the advantage of amplitude modulation? It can easily transmission and reception. You can easily transfer the signal and we can receive the signal. Lesser bandwidth requirements, low cost. But limitations of amplitude modulation. Noise level is very high. Here, noise means it is unnecessary frequency or unnecessary signal or unwanted signal is mixed with the frequency. That's called noise level. Noise level is very high in the amplitude modulation, and it is low efficiency. The efficiency of the wave is very low, and small operating range. That means we won't transfer it in a very long distance. Next one, we are going to see the frequency modulation. So frequency modulation again, see amplitude modulation, this one. Frequency modulation. So this is the frequency modulation. First amplitude modulation, we are changing that amplitude of the wave, remaining frequency and the phase are constant. We won't change the phase or the frequency. So that is called amplitude modulation. Now frequency modulation. Frequency modulation means we are going to change the frequency of the wave, remaining phase and amplitude are constant. So here we are not going to change the amplitude, we are not going to change the phase, but only we are going to change the frequency. So here see that with the input signal. So input signal, again you can see that A, B, C, D is the input signal, and this is the carrier wave. So it has a high frequency carrier wave. So here the input signal is superimposed on the carrier wave. See the portion OA, it's the positive half of the cycle. So it is a positive side. So it is here that frequency, see that it's a carrier wave. See here the red color line, the carrier wave OA is that's a compression. It has a large number of frequencies. And see that B is a negative half of the cycle. It is negative direction of the wave. See here the negative side, it has the large amount of space, that is rarefaction. Here the frequency is larger, here frequency is less. Again you can see that for C the frequency is larger and D frequency is less. So here that it occurs compression and rarefaction. Compression and rarefaction, like that, that wave is transmitted. So this type of transmission is called frequency modulation. The frequency modulation is the input signal. It's the high frequency carrier wave changes in accordance to the input signal is called frequency modulation. You can hear the word FM radio. That is frequency modulation. That's only you are calling FM or like that. So frequency modulation. Okay. Next one. After that frequency modulation, what is the advantages in frequency modulation and disadvantages? Advantage of frequency modulation: large decrease in noise. Amplitude modulation has a large noise, but in FM modulation, the noise is less. This leads to an increase the signal noise ratio. The operating range is large, but AM is less. The transmission efficiency is very high, but transmission efficiency in AM is low. FM bandwidth covers the entire frequency range which human can hear. Due to this, FM radio has better quality compared to the AM radio. That's why FM radios are used here instead of AM modulation. So what is the limitation of the FM wave, or what is the drawbacks? FM requires a much wider channel, but AM requires only a small channel, but it requires large, wider channel. FM transmitter receivers are more complex and costly, but AM is simple and very low, but it is a more complex and costly. In FM reception, large area is covered compared to the AM. So AM FM it covers the larger area. The last one is phase modulation. In phase modulation, definitely you know that we are going to change the, what we are going to change? Phase. Remaining two factors, frequency and amplitude is constant. Only we are going to change the phase. So instantaneous amplitude of the baseband signal modifies the base of the carrier signal, keeping the amplitude frequency constant is called a phase modulation. The phase modulation. The phase modulation, again you see that this is the carrier wave and this is the input signal. So when the input signal is superimposed on the carrier wave, see here the phase of the value is not constant. Initially, the negative half of the cycle, the phase is very large, carrier wave, and this is the phase, and depending on the phase, the phase of the wave is changes here. So this is a modulated wave. So this is a carrier wave, the signal and modulated wave. Here the negative A is it has a large angle difference, but B it has a very small angles. So the phase of the wave is changes here. So that carrier wave is changes according to the input signal. The advantage of phase modulation is, frequency modulation is produced from a PM signal is very stable. Here that phase for frequency modulation, it is a stable, but compared to the PM wave, PM is very stable compared to the FM modulation. Then the center of frequency is called resting frequency. Here you see that without applying that any input signal, this wave is called a carrier wave, and this is input signal. Okay. So this is called a input signal. So without applying that any input signal into the carrier wave, that signal wave is the carrier wave is called a resting frequency, or it's the carrier wave frequency. So resting frequency is extremely stable. So without applying that any frequency, the R is called center frequency. So for an example, the carrier wave is 100 kilohertz, and this is 10 hertz, means the 10 hertz it is added to the carrier wave. So before adding that signal, it has a 100 hertz, that is called resting frequency or center frequency.